All right, let's dive right into this explainer. Today, we're taking a single Python Flask app and evolving its Docker file through 5 distinct versions. We're going to take the exact same application code and transform it from a naive, bloated 1.24 gigabyte monster into an ultra-secure 87 megabyte production-grade powerhouse. Whether you're brand new to containerization or you've been using Docker for a while but feel like your builds are just sluggish and heavy, you are absolutely going to love this breakdown.
Here's our roadmap for today. We'll be looking at Dockerfile basics and vocabulary, shrinking the base image, troubleshooting the layer cache, multi-stage build speed, securing the production environment, and finally, your production checklist. We are covering everything from layer caching to security so you know exactly what belongs in your mental model.
Okay, Section 1, Dockerfile Basics and Vocabulary. Real quick, before we look at those 5 versions, we just need to establish the language of a container image.
A Docker file is essentially a sequential list of instructions, executed top to bottom. And here is the crucial thing to remember. Almost every instruction, like from, copy, and run, creates a brand new cached layer. Think of a layer as a saved snapshot of your files. Docker builds your images layer by layer, and it caches them. Keeping that cache in mind is absolutely vital as we optimize our code later on. Because, as you've probably experienced, breaking that cache is exactly what causes those incredibly frustrating long rebuild times. Notice that CMD down at the bottom doesn't create a layer. It's just metadata.
Moving on to Section 2, Shrinking the base image. Let's look at the naive Docker file that most engineers write first and see exactly why it's completely unsuited for production.
Believe it or not, this simple 4-line file has 4 massive mistakes. We're using the massive default Python base image, we forgot to ignore local files, we aren't pinning our package versions, and, perhaps the most dangerous one, we're using a shell form CMD. The shell form basically wraps your startup command in a standard shell, which intercepts the termination signal. That means your app literally can't shut down gracefully, and Kubernetes or Docker will eventually just forcefully kill it 9 seconds later. Not good.
Because of these really common mistakes, our version 1 image bloats up to a staggering 1.24 gigabytes. Not only is that incredibly slow to push and pull over a network, but it also creates a massive security attack surface. It's packed with gigabytes of compiler tools that your app simply does not need to run.
So, let's fix this in version 2. First, we format our startup command as an exec form CMD. You'll notice those JSON-style brackets. That tiny change ensures system signals go directly to your Python process so it can actually shut down properly. We're also explicitly defining our working directory here so we aren't just sloppily dumping files into the root of the container.
But the biggest win? By simply switching our base image from that full Python image to the Python 3.12 Slim variant, we strip out all those unnecessary compiler toolchains and development headers. Our image size dramatically plummets from 1.24 gigabytes down to just 186 megabytes. That's a massive boost to your security posture just by changing one word. Getting rid of those extra tools drastically reduces false positives and real vulnerabilities when you run automated image scanning in your CI/CD pipeline.
All right, Section 3, Troubleshooting the layer cache. Right now, our version 2 builds super fast the first time, but if you change even one line of source code, it takes almost a full minute to rebuild. Why is that happening?
Well, it all comes down to the order of your instructions. If you copy all your frequently changing source code before running your pip install, every single time you edit your code, boom, you break the cache for that layer. That forces Docker to download and install all your packages from scratch every single time. If you're ever troubleshooting inexplicably long rebuilds, this is almost always the culprit. The correct way to do this, which we're doing here in version 3, is to copy your rarely changing requirements file first. You run that expensive pip install step, locking in that cached layer, and only then do you copy the rest of your source code. By fixing that cache order, your source code changes only invalidate the very last cheapest layer. We also added the --no-cache-dir flag, which stops pip from baking 50 megabytes of useless download cache into the final image. The result of these 2 tweaks? Our rebuild time drops from 58 seconds down to just 0.8 seconds. That is a total game changer for how fast you can iterate during daily development.
Section 4, Multi-Stage Build Speed. We're sitting at 186 megabytes right now, but we can actually do even better using multi-stage builds.
Multi-stage builds are awesome because they let us completely isolate our build environment from our production environment. We install all our dependencies in a bulky builder stage using tools like pip and wheel builders, which are just used to compile C code for Python. Then, we start a completely fresh, clean runtime stage, and we use the -- from builder command to copy over only the final installed packages. By ditching those heavy build tools in the final stage, we drastically speed up our daily development cycles and our image size drops again, this time down to just 91 megabytes.
On to Section 5, securing the production environment. We're tiny and fast now, but there's a big red flag. Our app is still running as the root user.
Running as root inside a container is a massive security flaw, guys. If someone manages to break into your app, they suddenly have root access to that entire container environment. So, for version 5, we enforce a non-root user. Specifically, we use UID 1001, which maps perfectly to Kubernetes security contexts, preventing privilege escalation. And to make sure this user actually owns the files we're copying in, we use the -- chown flag right inside the copy instruction. That sets the file ownership atomically in a single layer, which is much cleaner than adding a messy separate run command.
This step also brilliantly shows how we prep for real production traffic. We finally swap out that flimsy, single-threaded Flask development server for Junicorn, a proper production WSGI server that can handle concurrent requests. We also set Python unbuffered = 1, ensuring our logs don't get trapped in a hidden container buffer so they stream instantly to our observability tools. And finally, we add a health check. This makes the container self-reporting, so Docker and Kubernetes actually know when the app is genuinely ready to receive traffic.
And there it is. This perfect version 5 iteration leaves us with an ultra-secure, highly optimized production image weighing in at exactly 87 megabytes. Think about that. We started at 1.24 gigabytes. We are now 14 times smaller, running as a restricted user, and our dev rebuilds take less than a second.
Let's wrap things up with Section 6, the final production checklist. Let's do a rapid-fire roundup of these best practices that need to be in your mental model before you ship any container.
First up, you absolutely must understand the difference between arg and env. This is a super common trap. Arg is for build time variables only, while env is for runtime environment variables. Never, ever use arg to pass secrets or passwords into your build. Why? Because anyone looking at the image using the Docker history command can read those secrets in plain text. No way! Always use secure secret managers for your sensitive data, and reserve env for standard app configurations and paths. So here is your final production checklist. Use slim or distro-less base images. Always cache dependencies before your source code. Use multi-stage builds to isolate tools. Enforce a non-root user with an explicit UID, and always use execform CMDs. Oh, and if you take one thing away from this, never forget your .docker ignore file. If you leave it out, your local .env files, the ones with your personal API keys and database passwords, can accidentally get permanently baked right into a public image. Exclude your secrets, your Git history, and your cache folders for sure.
Well, that concludes our Docker file evolution. You now know exactly how to craft a highly optimized, production-ready container. But this does leave us with one massive, fascinating question. Once these secure, tiny containers are actually running, how do they discover and communicate with each other over a network? I mean, how does your front end actually talk to this newly optimized backend? That's a whole new layer of the puzzle and definitely something to think about as you deploy your applications.